In this third video about regions of space, what I would like to do is just do some very quick sketches of some easy regions of space. These are not accurately drawn, they're just a sketch so that you have a general feel for what an accurate picture should turn out if you're using tables of values to plot things more accurately. So for example, if I said to you, we're going to do a region of space which must obey x is less than 4, y is greater than -2, and at the same time y is less than 3x plus 4. So if I was to say, let's sketch the region which satisfies those three, this is going to be very quick. I'll set up a very quick cross wire, y and x. I am not going to put on an accurate scale, I'm just sketching this now. X is less than 4, so we need to go to 4 on the x-axis. X equals 4 would be the boundary, so that would be a vertical line in dots because there's no equals. In fact, all of these are going to be in dots, there's no equals. And less than means the arrow would be going to the left, like so. So there's the starting point. Next one, y greater than -2. So you go to -2 on the y-axis, no scale needed, just mark it on down there on the negative y scale. Dotted line going across. That's the boundary y equals -2. Y needs to be bigger than, so arrows going above, like so. Thirdly, I need to show y values less than 3x plus 4. So what I'm going to do is just sketch the line y equals 3x plus 4. From our previous straight line graph work, we know the plus 4 on the end tells you it's going to cross at 4 on the y-axis. And we also know it's got a +3 gradient or slope value, which is going to be going something like that. Now, because we haven't got a scale, it doesn't matter whether I draw it shallow or very steep, because there is no scale to give us the exact slope of the line. But it is going to be a positive slope, crossing at +4, and so I'll draw something like this. Remember, it's dots once again. I'll just extend that a bit. I'll draw something like this. Dotted line, something like that. I'll extend that line as well, so the lines intersect. And y values must be less than this. So we're going to have to put arrows going down like so below it. Label it with its equation of the boundary. So there's a very quick sketch of what's going on. It must be below that diagonal, above that straight line, and to the left of that boundary line. So this would give us a region which is in the central triangle that you can see. There you go, there is a sketch of that series of conditions as a region of space. Okay, so that's much quicker because we do not have to plot accurate scale, we don't have to plot a table of values. Okay, so remember, you can only do this if the question says sketch. Okay, so number 2, let's do another one. For number 2, I'm going to give you these conditions. Number 2, -3 less than or equal to x, in turn less than or equal to 2. I'm also going to give you another boundary line, y is greater than -2x minus 3. I need to show the region which obeys those two conditions. A sketch, not accurate, so no tables of values at all. So I'm just going to set up my cross wire like so as a sketch, and I'm going to say, right, the top one there, -3 less than or equal to x less than or equal to 2, basically means that x values must lie between -3 and 2. So I'll go to here, somewhere there, -3, and it's a solid vertical line because we do have equal signs available. Label it, x equals -3. 2 is needed, so I'll go somewhere there, vertical line, solid, x equals 2. And that inequality means that the x values lie in between those two boundaries. So arrows here to the right and at this end to the left. So in between that region. Okay, I now need to look at this diagonal boundary line, so I'm going to plot y equals -2x minus 3 as a sketch. And it's going to be dotted because there's no equal sign. So if you think about it, -3 at the end tells you it crosses at -3, somewhere down there on the y-axis, and a -2 slope means the slope must be going that way. We do not concern ourselves with how steep because this is only a sketch. So I'm going to do a dotted line that is sloping something like so. And that is the boundary line y equals minus 2x minus 3. Now y values need to be bigger than the minus 2x minus 3, so that means we go above the line like so. So above, above and above. Okay, so what we need is to shade the region which lie in between the two vertical lines and at the same time must be above that diagonal line. And if I do this perhaps in a colour, so you can see that we have this region here which satisfies the three vertical lines, the three boundary lines that we are drawing. Notice, I nearly went too far there, that it's going to be to the right of that, so I do not have this region shaded in here. Okay, so that there is not shaded in. So it's that region there between the two verticals and above that diagonal which we need to concentrate on. And there you go. We've got three very quick and easy sketches of regions of space. Remember, however, to read the question. Most questions require you to do an accurate diagram, and they would not be good enough if that was the case. You need tables of values, and we will do some harder examples of accurate diagrams in the next video.